Alright guys, so in the last video we looked at the derivative and what that means. We're going to look at the second building block of calculus today, which is the integral. Alright, so now when we look at the integral, the idea behind it, derivative was of course the tangent curve at any given point. What the integral is actually kind of the opposite. It's the area beneath the curve. So we're not trying to pinpoint a point and find something specific about that point. We're trying to look at the big picture and look at the graph as a whole. And so sometimes it's helpful, those that have taken physics or something like that know that it's often helpful to know the area underneath the curve. So for example, let's say we wanted to know the area beneath the curve between 1 and, or between 0 and 3. And so this whole area, which I'm going to outline in red here, let's say we want to know that area. Now if this were some type of trapezoid or rectangle or something, it would be really easy to find the area of that. But since it's a curve, it's going to be a little bit more difficult to find out exactly how big that area is. Now, one of the things that we can do is similar to what we did with the derivative, is we can break it into pieces. Okay, so that's what we're going to do. We're going to take it and we're going to break it into rectangles, which will be easier to work with. Now, for the first group, I'm going to use rectangles that go over to the 1 by unit. And so I'm going to use a rectangle like this, and then we'll go and we'll make another rectangle right here, and we'll make another rectangle right here. And you can tell that if I can find the area of those three rectangles, it will approximately give me the area of the curve underneath the curve. Alright, so that's what we're going to do. We're going to say, okay, well this rectangle is 1 wide and 2 high. So 1 times 2. I think we're going to need a different color there to make sure that you guys can see that. Okay, now the second rectangle is also 1 wide, but it's 5 tall. So 1 times 5. Alright, and then the last rectangle is 1 wide, but it's 10 tall. So 1 times 10. Now, if we add all those together, 2 plus 5 plus 10, then we get 17. Now, you'll notice that each of these rectangles is a little bit bigger than the area that it's supposed to be representing. So we know that the area of the curve is going to be less than 17. So what we can then do is we can say, okay, well, we did it using the right corner, which is called an upper rectangle. But now let's do it with the lower corner. And so instead of going up to this point, on my second graph here, I'm going to do the same thing, except I'm going to draw my rectangle where the left-hand corner is on the graph itself. Okay, so like this, and then over like that. Now obviously you can tell that these rectangles will take up an area that's less than the shaded area. But again, I should be able to do this and find the areas of each of those rectangles. So this one is 1 wide and 1 tall, plus this one is 1 wide and 2 tall, so base times height, and this one is 1 space wide and it is 5 spaces tall. So we can then solve that and we get 5 plus 2 plus 1, which is 8. So we know that the area under the curve has to be more than 8 because this one underestimates, and then we have less than 17. So we figured out that x has to be between 17 and 8. Now what you can do is you can average those two and you can get the average rectangle, which would then be halfway in between. But what we want to do is we want to get a little bit closer. Alright, so go on to the second video and I'll show you what we're going to do to try to get a little bit closer. Alright?